Insurance, okay.
Sir, okay.
So hearty welcome to all the participants for this webinar by Dr. Aruna Shekar Madam. And I also welcome all the participants who have registered, joined with us to have a nice benefit out of this talk on the topic of innovation and design thinking. And before that, I'd like to invite our principal to say a few words about the college and also welcome all the dignitaries on the webinar session. Please, sir.
A very good morning to one and all present in this webinar. On behalf of respected Chairman, sir, members of the management, all the faculty members, students, and my own behalf, I wholeheartedly welcome Dr. Aruna Shekar, Professor, Massey University, New Zealand, to conduct this webinar on Stay Ahead through Product Innovation and Design Thinking. Thank you, madam. Welcome, madam.
Thank you.
I also welcome the eminent members for panel discussion of this webinar event, Shri K.R.A. Nair, former Director, Lucas TVS, Shri S. Krishna Kumar, former Vice President, Lucas TVS, Dr. C. Jebaraj, former Professor, Anna University, and Dr. Saktivel, Dean, University College of Engineering, Anna University, Kanchipuram. Welcome you, sirs. I also welcome all the elite participants who have registered and participating in this webinar organized by Mechanical Engineering Department of our institution. My dear participants, hope you are all doing fine and safe during this pandemic period. To enrich our knowledge with respect to our area of interest, our management strongly support us to organize such webinars for the benefit of all the faculty members across the country and outside the country, and also for our students. So far, we have conducted nearly 200 webinars for the benefit of our students, faculty members, and also faculty members of all the other institutions by our proud alumni in India and abroad, and also our own faculty members and the eminent resource persons from industry and academia. I would like to share some information, including the major achievements of our institution to all the participants. Our R.M.K. Engineering College, established in the year 1995, situated at Kavaraipettai, Kummudipundi Taluk, at a distance of 30 kilometers from Chennai. We are at the forefront of engineering education, consistently among top 10 engineering colleges in the state. Our graduates percentage in the year 2019 was 89.6%, and the overall result was 93.82. And there are 200 plus regular recruiters every year to offer placement for our students, and we have been maintaining consistently above 85% annual placement conversion. In the day one campus placement 2020 batch, totally 816 offers were issued by Cognizant, TCS, Wipro, and Infosys to our students from R.M.K. group of engineering colleges. Our R.M.K. management team, consisting of our Honorable Chairman, visionary through R.S. Muniratnam, founder chairman, a dynamic personality, a great visionary and philanthropist, former member of Tamil Nadu Assembly, elected 3 times in succession. He was instrumental in setting up industrial estate, SIPCOT, and Institute of Road Transport at Kummudipundi. At present, he is the president of Consortium of Self-Financing Professional Arts and Science Colleges in Tamil Nadu and also chief patron of All India Federation of Self-Financing Technical Institutions across the country. He is honorary advisor for Youth Welfare and Sports Development Departments, Government of Tamil Nadu. For his outstanding achievements in the field of education to the rural community, he has received Vidya Ratna Award. Our management team consists of our chairperson, madam, director, sir, vice chairman, sir, secretary, sir, vice chairperson, madam, and also our management trustee. This is our 25th year of excellence in technical education. First approval received from AICT in the year 1995, approved by AICTE and affiliated to Anna University. And all the UG programs are accredited by NBA, National Board of Accreditation, New Delhi. And our institution is accredited by NAC with A+ grade, and Tata Consultancy Services accredited our institution with B grade. We have a total land area of around 35 acres, and we have been maintaining faculty student ratio of 1:15. And we have applied for getting autonomous status from Anna University and UGC for the academic year 2021, and the application is under process. In our institution, at present, we have 7 UG programs and 3 PG programs. UG programs in civil engineering, CSE, EEE, ECE, electronics and instrumentation, mechanical engineering, and information technology. We have also applied for getting new courses in BTech Artificial Intelligence and Data Science, BTech Computer Science and Business Systems, subjected to approval by AICTE and Anna University from the academic year 2020-21. We have 3 PG programs in Applied Electronics, Computer Science, and Power Electronics. And 6 departments are recognized research center by Anna University to conduct PhD program. And there are 150 candidates pursuing PhD with the help of recognized supervisors from Anna University in our institution. With respect to achievements and recognitions, we have received Best Overall Performance Award from ISTE in the year 2008. And in the India rankings, NIRF 2019, we have got 157th position. And with respect to cleanliness, greenery, maintenance inside the campus, and hygiene maintenance inside the campus, we have got 6th position across the country in the Swachhta ranking by MHRD Government of India. In the AICTE CII survey, Best Industry Linked Institute Award in 2015, our ECE department has received this award, and in 2018, CSE and IT departments have received. And in 2019, Mechanical department has received this Best Industry Linked Institute Award in the AICTE CII survey. From the inception of our institution, 955 university ranks have been backed by our students, including 23 gold medals. And we have been maintaining 96.11 graduates percentage, and so far 14,554 graduates gone out of the institution. With respect to industry collaboration, we have a very strong connectivity with all the industries, including core companies. With respect to this, we have established 14 Center of Excellence laboratories in collaboration with various industries. NAC has approved our institution to mentor 10 institutions to get NAC accreditation. We have also received Best Institutional Food Safety Award from the Government of Tamil Nadu. We have also organized TEDx during 2019. In the Smart India Hackathon competition conducted by AICTE and MHRD, 2 teams won first prize in Software Edition 2018, and 2 teams won first prize in Software, and 1 team won first prize in Hardware Edition 2019. And in 2018, our institution is identified as Nodal Center to conduct the Smart India Hackathon in our institution, one among the 28 nodal centers identified by MHRD. In this, Honorable Minister of State for Housing and Urban Affairs, Sri Hardeep Singh Puri, has felicitated during the valedictory function. And 40 teams of 240 students with mentors participated in the 36 hours continuous hackathon. In the AICT Chhatra Vishwakarma Award, our students bagged 3rd prize. Prize given by Honorable Vice President of India. We have approved MSME Incubator and also ECEL, approved by EDI Anna University. We have adopted 5 villages in and around our institution near Kavaripettai under Unnat Bharat Abhiyan 2.0 by MHRD. And in the MHRD's Institution Innovation Cell, we have got 4-star rating. With respect to top magazine rankings in the year 2019 and 2020, so our institution is ranked 10th position, 13th position in the private and also in the top 100 by other leading magazines. And in collaboration with industries, we have established 14 Center of Excellence laboratories, particularly with respect to mechanical engineering department. We have product lifecycle management COE laboratory in association with PTC. Our students attending training under this PLM COE are getting placement in various companies, including core companies. With respect to training and placement, all the students of our institution are provided with 360-degree structured training program, and placement percentage with respect to 2020 batch, 88%. We have a very strong alumni association with chapters in and around inside India and also in abroad. Last year, our chairman sir visited USA and inaugurated the USA alumni chapter and conducted alumni meet at 5 different places, and around 500 alumni have participated in this alumni meet conducted by our chairman with their family. With respect to infrastructure and facilities, we have well established e-cell, and every year 5% to 10% of students are becoming entrepreneurs. So in the last 3 years, so there are 23 startups by our own students, including 10 lakh rupees grant through Startup Nidhi project by DST, backed by our students. And we have Center for Higher Education. Every year, 15 to 20% of students joined in reputed institutions for higher studies in India and abroad. We have also Center for Foreign Languages. Japanese language training program has been conducted in our campus. Last year, around 50 students have got placement in Japanese companies with a salary of 14 lakh yen per annum. We have Center for IPR and Patents. So far, 25 patents applications filed by our students and faculty members, out of which 15 got published. We have Center for Online Learning and also Center for Faculty Development to conduct various faculty development programs for the benefit of our faculty members and also faculty members of various engineering institutions across the country. We have a very well-established computing facility with 1,080 computers and also smart classrooms, well-stacked library with 99,000 and odd books in various titles, digital library, and also all the e-journals are subscribed. We have health center, and transport facility has been arranged for all the faculty members and students. We are operating buses in 16 major routes. With respect to sports facilities, we have all sorts of sports and games facilities for the benefit of our students. Every year, our students are participating in various sports and games events conducted by various agencies, including an university journal tournament, and won prizes. They have boys hostel, girls hostel, AC gymnasiums in both boys and girls hostel, and general facilities, including parents waiting hall, and also to provide uninterruptible power supply, full capacity genset is available in the campus. Bank, ATM, and also effluent treatment plant for gardening purpose and for safety measures are also well taken by our management. Our R.M.K group of institutions consisting of 3 engineering colleges, including our R.M.K Engineering College and RMB Engineering College and R.M.K College of Engineering and Technology, and 1 polytechnic, Sri Durga Devi Polytechnic. And there are 4 schools out of CBSE and metric, and 3 schools are situated at Kavaraipetai, including 1 R.M.K Residential Senior Secondary School, and 1 school is situated at Thiruverkadu, R.M.K Padasala, CBSE school. Thank you for the given opportunity. For further details, please visit our website www.rmkec.ac.in. Once again, I would like to welcome Dr. Aruna Shekar, Professor Massey University, and all the elite participants and also panel members, distinguished panel members for this webinar arranged by Mechanical Engineering Department of our institution. Thank you for the given opportunity. Thank you.
Thank you so much, sir, Principal sir.
Thank you, sir. Now I invite Dr. K.R. Sedil Kumar, HOD, Department of Mechanical Engineering, say a few words about the department and introduce the guest. Please, sir. HOD sir.
Yes, sir. Yes.
Sir, please say a few words about the department
Sure.
and introduce
Very
the
good
guest.
morning to all the participants, the chief guest, Dr. Aruna Segar, our principal sir, and the dignitaries, Dr. Nair sir, Krishna Kumar sir, Jabaraj sir, and our dean sir, who is in US. So a very warm good morning to all of you. So it's my great pleasure to introduce our Department of Mechanical Engineering to this August gathering. The Department of Mechanical Engineering has been the accredited department. Regarding academics, it pronounces we produce consistently top university rank holders, 7 gold medalists, and 100 plus university ranks. And in the recent year, we have consistently, for 2 years, backed up the gold medal. Mr. Ranadir have got the gold medal in 19 batch, which is the last year. And regarding ASATCA survey, it was awarded to us with the best industrial linked institute for mechanical engineering in the year 2019. Not only in that, in the professional society, we got the best chapter award. In institution of engineer, we got the best student award. And as a faculty team, we have former IITians with 7 PhD, 9 faculty members doing PhD, and a distinguished professor, Dr. Krishna Kumar from AICT, INEA Distinguished Professor, approved by AICT. And we have the state-of-the-art infrastructure, including the coordinate measuring machine, friction and wear monitoring machine, compression molding machine, engines with data acquisition system, 3D printer, and advanced software tools. And in research funding, we have projects worth of granted 55 lakhs from different agencies like AICT, AQIS, DST, ISRE, and TNSCST schemes. The faculty industry collaboration is very strong in our department. The services offered to the industries like tractor and farm equipment staffing, Mrs. Venus Auto Components, Trimala Industries to tune of 4 lakhs. 4 lakhs consultancy we have made every year. The students' placement, they are placed in core IT jobs and IT-enabled services industries such as Turbo Energy Limited, Simpsons, and Mitsubishi TAFE, MRF, Amar Raja Batteries, BGR Energy, Saint Gobain, and in IT-enabled services like TCS, HCL, CTS, Wipro, etc. And we have around 76% of placement, and also around 20% of the students go for higher studies abroad. Regarding the COE, Center of Excellence Lab establishment on product lifecycle management, to bridge the gap between the institute and industry and to take up the industrial expectation into our students' minds, the management has invested 1 crore of rupees towards 100 license installed in our department with Creo modeling software and Windchill PLM software on infrastructure and development. The PLM Center of Excellence of R.M.K is an authorized training center in association with PTC, Parametric Technology Corporation, for training the students for 125 hours apart from academics. And the certificate program given by PTC is issued to the students, and over 500 plus students have been trained in this domain. About the extracurricular activities, students constantly participate in SAE Baja because whatever they have learned, it should not go waste, as it has to turn into some projects and competition they have to win, so that to get recognition from reputed organizations like SAE Baja, Formula Bharat, Smart India Hackathon, project competitions at IIT Mandi, our students have won. Project competition like IIT Guwahati, they have won. Not only in national, but in international conference also, our students have won the best paper award by Raja Sabarinath and his team. About the authorized training center, it is a value-added training program. Apart from syllabus, we not only go for the syllabus content, but our students write exams in NPTEL, Udemy courses, and also they have a focused industrial visit to ISRO, steel industries, TVS group of companies, and so on. They do some innovation project for competitions. They participate in conferences They publish patents and publications or through corporate contest also is motivated. So our alumni have a passion and they are at a very settled position. So if you see in our placement department, they are giving a 360-degree career guidance program within the campus. So you can see the number of hours, 576 hours apart from academics training is conducted for in 4 years. As an outcome of all these things, as our NBA Board of Authority says, outcome-based education is very important. We have distinguished alumni. To name a few, Mr. Shekar is a lead engineer in General Electric, and Mr. V. Karthikeyan is a design engineer in Caterpillar, North Carolina, USA, and Mr. Ganesh is a PhD scholar at National University of Singapore, and Mr. G. Ranadir is a MS scholar at National Institute of Singapore, and Mr. Padmanabha Prasanna is a production assistant executive engineer at production ONGC Limited, and Mr. Lokesh Babu is also a PLM developer in HCL Technologies. So these are few outcomes. I hope you would have got a good appreciation about our department. So now I feel delighted in inviting all the peoples again, and I am very much honored to introduce our chief guest also for this webinar, Dr. Aruna Shekar Madam. Everyone can be more innovative in any discipline or role. In this session, you will learn how to approach creative problem solving and innovation in systematic way. Aruna Madam presents how to move from opportunity identification to implementation of ideas with real world examples. She encourages the application of design thinking, process, and methods for successful solutions and outcomes. Aruna Madam has taught 25 years as senior lecturer in product design at Massey University, New Zealand. She has developed the creative critical thinking skills of students through project-based courses. She has coordinated projects in humanitarian engineering to encourage young students to understand the social impact of social science and engineering in society. She has led the first year school innovation course in conjunction with Engineers with Borders, and her students have won national awards. Aruna Madam has many publications in international journals and conferences to her credit, including contributing chapters to many books on product management. Aruna Madam has served as a foundation president of Product Design and Development Management Association, PDMA, world-known organization in New Zealand, and continues on board, appointed as Vice President, Asia Pacific for PDMA USA in 2017. She leads the global chapters in the region, Australia, India, Indonesia, Korea. Aruna is certified as a trainer by PDMA. As an educator, she continues to champion the application of design thinking and product innovation skills to generating meaningful solutions. Her passion to help people develop their innovation mindsets so that they can solve problems and create better world. So with these few words, I invite Aruna Madam for her innovative speech for this August gathering. Please, Madam.
Thank you very much. I really thank the principal and HOD and for all the kind words and the distinguished panel we have, and each one of you that has registered. I really, really thank you all for joining in. So I will start off by giving a brief introduction about myself, and then I will talk about innovation and design thinking. Thank you for inviting me to speak about that. And then I will go through some of my examples as well. Let me just share my screen. Okay, so is the screen visible to everyone?
Yes, Madam.
All clear? Okay. So the topic today is to stay ahead through product innovation and design thinking. We all know that we are in a very challenging environment at present with COVID, but this is exactly when you need to be creative and you need to innovate because things are going to be different. And this also presents challenges, but it also presents a lot of opportunities for innovation. So I think this is the best time. In fact, I have a little analogy that we have of two carpenters or woodcutters who are cutting wood. And I feel there's one person who takes a few breaks and sharpens his axe and then gets back to cutting the wood. And the person who takes the breaks actually is more effective and efficient than the person who continuously keeps chopping the wood. So for me, this is the time to sharpen our axe and upgrade and learn new skills and new methods and tools so that we can be more creative and more innovative going forward. So I will start off first by just telling a little bit about myself. I've already been introduced, but I thought I'd just tell you that I came to New Zealand about 30 years ago, and I've been with Massey University teaching product development. I have been teaching more the product management side, but I've been teaching within the School of Engineering. So we've been teaching product development across all of the disciplines because it is something that is applied right across electronics, mechanical, mechatronics, even food development, because food is a huge industry in New Zealand. I'm also a certified trainer. There's a certification program offered by PDMA, which is the Product Development and Management Association in the US. And I'll tell you a little bit more about that organization as well. In fact, for the students who are online today, there's a very interesting student product innovation competition. So I'd really encourage you to have a look at the PDMA website and put in your entries for the student competition. I collaborate with Stanford University. I've been there with Dr. David Kelly and Larry Leifer. I don't know if you all know or have heard of a company called IDEO. It's a design consultancy in the US, a really very big one, which David Kelly founded. And design thinking has actually grown from there and popularized by Stanford University. Although we were using different forms of the process, they actually made it very popular and called it design thinking. And I was invited to speak about that. So I'm really honored to do that. I do conduct a lot of training as well on product innovation and basically applying the practical methods in projects. So the pictures that you see at the bottom of my slide, they are just a couple of projects that we won awards in. We won awards on many others, which I can share each time, but these are just some of them. One is an affordable cooking system for a village in Nepal. And the other one is on air quality studies with schools. So we are teaching students how to understand and measure air quality inside the classroom and outdoors as well. So the PDMA, for those who haven't heard of it, it's a Product Development and Management Association established about 40 years ago. And they have a huge source of knowledge and body of resources. In-depth studies on best practices. In fact, they conduct a study every few years with thousands of companies to find out what are the leading practices in product development. And they have the best companies versus the rest. And they found that the best companies actually use some of these processes that I'm going to show you today. And the training involves setting the strategy in a company, portfolio management, the process. Design thinking is one process. Organizations, teams, culture, tools and metrics, how to measure performance in product development, market research, and life cycle management. So all of these topics, once you cover all of this, you take the certification, that's the certificate, that's what it'll look like, and you can have your name there once you pass the exam. So now to some of New Zealand's famous innovations. I've just picked a few. I'm sure India has a lot as well, and it'll be interesting to learn about some of those. But there's a huge difference between New Zealand industry and Indian, of course, because in New Zealand, we have 90% SMEs, small and medium enterprises. So we've got a lot of tiny little companies, but they're multinational. So that's very interesting. We actually call them mini multinationals because the domestic market is so small that they've got to export. So even if they're a tiny little company, they are exporting to about 30, 35 countries. So we've got the Hamilton jet, we've got bungee jumping, that's leisure and sports because New Zealanders are very outdoor people. And agriculture and food is a huge industry here. So we've got Fonterra, which is a huge company producing a lot of milk and cheese products. And we've got the cereal company. This is actually developed by a person from Massey University, and he's doing really well as well. So there's just lots and lots of innovative products coming through. So in this session, what I'll be covering is design thinking. I was invited to talk about that, and it's just going to focus on the process itself and the different stages within that. It's also going to teach you about problem solving in a more creative as well as systematic way. So there's certain principles that I'll cover which can apply to any project, particularly for students. When you're approaching a project, if you apply some of these methods, it'll just help you reach successful outcomes. And right through, I'll go through some examples and case studies as well, because I find that is really interesting. Innovation and creativity actually prepares people to succeed in a rapidly changing environment. And that's exactly what we are in now. Things are changing very rapidly. Some of the things we don't have control over, but this is when we've got to plan and see where we want to get to, what are our goals, what are the tasks that need to be done to get to those goals, and how are some of these tasks impacted by the current environment. So let me start with some definitions. What is product innovation and new product development? Just so everyone understands and we're all on the same page. It is a process of creating something new or improved goods or services. So it's a wide range. It's not only the breakthrough radical innovations, but also the continuous improvement that companies make on products. It's the creation of solutions that meet new requirements or new needs. Innovation is crucial to the success of any organization. All companies need to continuously innovate. Otherwise, they cannot survive in the market. They've got to come up with something new. And you've got to have the process systemized so that there is a continuous stream of new products, not just one. So the basics is to do the right NPD. NPD basically is new product development. So doing the right NPD project, it's all about portfolio management, selecting the right strategy and aligning the projects to that strategy. Usually you apply the 80-20 rule. 80% of your projects should be the ones that are providing the profit and the growth in the market. Doing NPD right is all about the process. That is, you do it properly, and it's all about applying this mindset and approach. It's product development is a mix of technical, marketing, and finance. So ideally, a product manager should have the technical background, but also have the management and marketing knowledge. And that's why it's multidisciplinary. The scope of some of our projects within the product development degree is mainly we focus on consumer goods, consumer durables, and healthcare. But design thinking and the product development process applies across industry types and across industry sizes as well. Whether it's a small company, a startup. I was very happy to hear that some of your students have startups. Some of them have gone into as entrepreneurs, and you've got patents. Very, very interesting to hear about all of that. So what is design thinking? Design thinking, somehow people mistake it. It's not really just industrial design. it is actually design engineering. It is design of engineered products. It is a collaborative problem-solving approach, and it's got specific stages. It's got 5 stages. And it's usually applied when the opportunity or the problem is not very well defined and you want to explore different avenues for finding the right solution. So Tim Brown, who is the CEO of IDEO, the design consultancy, he says design thinking is a human-centered approach. So it's very much people-focused to innovation that integrates the needs of people, the possibilities of technology, and the requirements for business success. So it's all of those 3 components, the business, the marketing, and the finance. So these are the essential principles of design thinking. It's human-centered, so very much focus on users as the main people. What are their needs? What are their issues? What are their problems? It's got a bias toward action. So it means that the team doesn't just stay in the office and behind their desk, but they actually go out to the field. They find out from people what the problems are, go to the context. They do prototyping. Radical collaboration is, again, it's not done by one person. It's not a solo game. It is a team game. And it involves all the key stakeholders. That's really important to get all those different perspectives in. Culture of prototyping. I often have the problem where I have my students who tend to wait till the last, till they actually get a perfect prototype that looks exactly like the final product. But that's not the case. What we want is anything rough and simple, just to communicate the idea. So it could be anything that you pick up from the office and put together, and or even sketch on a piece of paper before you spend hours on CAD and design and all that. Okay, so you really need to get comfortable with making simple mock-ups to convey your idea, and then it'll evolve and develop into a proper prototype. Show, don't tell is, again, a lot of visualization. There are a lot of methods within design thinking, like personas, storyboards. All of those actually help visualize to the team and to the external stakeholders what their product idea is. So they use a lot of those tools. And finally, the principle of being mindful of the process is basically knowing where you are in that process of development, because at each stage, there are different activities and different methods. So you need to be mindful of where you are in that stage and what you need to be doing. So this is the 5-stage process. Some of you might have seen it. It starts with empathy, then you define, then you ideate, prototype, and test. And inside each of these, there are a whole range of activities and methods, but we won't have time to go into all of those methods. But I'll talk about each of those stages now going forward. It's a sort of a convergent and a divergent thinking process. So sometimes people refer to it as a double diamond process, because you start off wide, then you narrow down and define, then you go wide again for ideation, then you narrow down to you don't make all your ideas into prototypes. You only select 3 or 4 and make them into prototypes. And then you test and then launch the product. So that is the process that you go through. Although the diagram looks like it's linear, it's not. It's quite iterative. So there is a bit of iteration definitely in prototype, design, build, test. So you do evolve, as I said. So you don't have to get fixed to the first idea. You actually develop it right through, and it evolves. And it looks simple, but it is a lot complex, depending on the product type, of course. So in the empathy stage, you gather a lot of information, you listen and watch carefully, you understand the situation, you understand the competition, you observe people and what the task that they're doing and how you can make it easier for them. You actually immerse yourself in that context. So that's what they call it as deep dive. Is just basically spending time with your consumers and users so that you understand the problem fully. that is so important. Often students tend to jump to the first idea and first solution and they want to build it, but you've got to hold back and actually first understand the situation. What is the motivation behind the problem? Why is the problem occurring? And ask a lot of questions. I've got several methods to do that as well. How you ask a lot of questions so that you get to the root of the problem. And then you start looking for, other ideas. And it's quite shocking that up to 50% or more of companies are still not talking to their end users. Some of them don't even know who their end users are. They're so product focused that they lose touch with their users. And Albert Einstein said, insanity is doing the same thing over and over again and expecting different results. So there's no point, again, in this environment as well, for us to do the same thing, just like what we were doing before when things have changed. We've got to change along with the times. So we've got to do something different. And that's when you get together experts or people who are knowledgeable in that particular area, form a team, and then usually you have a champion or someone to lead that team. And then you start through the whole process of design thinking. So don't rush with your first idea. The second stage, which is define, is once you've gathered all that information through the empathy stage, you put it all together, summarize it, and define the need or the problem or the opportunity. And this is when you also decide on the scope. How much of the problem are you going to tackle? Are you going to only look at a small part of that problem or the entire problem? So you've got to decide that based on the budget and the time that you have and the resources that you have. And you can reframe it clearly so that the whole team is focused on that. So an example of, you can either have an open brief or a closed brief. So an open brief would give you a lot of scope for alternatives, where you might say, for example, you're looking at all furniture design. Or closed would be, I look at only office desks. So that'll be very specific and a narrow product category. So that's just an example. Or you might say, just design this umbrella or design this car, rather than say, how do we protect people from rain? So that would be an open-ended example. Protecting from rain, you can come up with any solution. It doesn't have to be an umbrella. So that's a decision you need to make when you define. After you got all those consumer insights, you clearly define what is it that you're going to tackle. And then you start with ideation, which is the third stage in the process. But often people tend to rush and they start with ideation. They say, oh, I've got this idea, or they've already got this product idea and they just build it and put it out, and then it fails. The failure rate is 75 to 80%. It's huge. The risk in product development is big. And that's why every other person is not coming up with new products. It takes time, expense, and expertise. And that's why you go through a process so that it actually improves your success rate. So once you come to ideation, then you generate a whole lot of solutions. The whole team generates solutions. You can even get your end users to come up with some suggestions and improvements. You use a lot of methods. Again, that's another whole workshop session where I can go through a number of methods. I've got this IDEO. I told you the IDEO design company. They produce this set of cards. It's a box full of cards, and each card describes a method, and there's like 50. It's about $50 or so. And then number of methods like analogy, user trips. There's just, because we want you to come up with a number of ideas. So we have methods that actually help you stimulate random and good ideas, wild ideas. We don't, it's like brainstorming where you don't criticize, you just generate as many as possible, so that after that, you will then select the best one based on certain criteria. And those criteria will be decided based on the objectives and the budget and the solutions that the users want. Stage 4 and 5, as you saw in that earlier design process diagram, is prototyping and tests. So rough mock-ups, as I said, just to convey the idea initially, because as you do that, you can see on the pictures that I've shown, they're just paper prototypes and cardboard. Should not take very long. And there's an important reason why that is so, because then you're not invested in it. You know, if you spend hours doing your CAD design and hours getting it 3D printed, you become emotionally attached to that idea, and then you don't want to let go or change direction. Whereas if you make it something simple like this and just say, hey, is this okay? Is this something that we are all thinking about? Then the team gets a good understanding and you can get some good, quick, early feedback. And I suggest even using Lego or Meccano or sticky notes and sketch and foam initially, and then you can go to your 3D printing. In fact, at IDEO, they did put this little example of a surgical tool, just very quickly from things that they found in the office, just simple prototypes. And then use this to get quick, early feedback. And you'll see it in some of my examples, how they've done the same process and methods. This is when there's a lot of iteration, design, build, test, design, build, test. And the other reason why this early prototyping is so important is, as design thinkers usually say, fail early, fail fast. They say that because it's much easier to fail early because it costs less. Product development can be very expensive as you ramp up, as you go through the concept generation, prototype development, scaling up to commercialization and launch can be very expensive. So you don't want to put the product out in the market and then realize that it has failed. You want to do all that testing much, much earlier. So as we've mentioned earlier, it's a combination of all these three areas: the technical side, the finance and business viability, and the human-centered. Is it usable and desirable? Do we have the capabilities, skills, and resources? And do we have a good market product fit? Okay. So now I'll go through some interesting examples. One is an American study, and then we have a Dutch study, and then I have a couple of New Zealand examples as well, where they've applied design thinking. And the unsuccessful one was because they did not apply design thinking early on. So the first example is the American company called Gillette. It's based in Boston. And very typically what they did was they had this razor, which was very successful in the American market. And they wanted to expand, like most companies want to grow bigger, and they wanted to expand into foreign markets, the new markets. And they thought, well, this product is doing really well in the American market. Let's put it out and launch it in the villages in India. And they did that, and it flopped. No one wanted it, no one bought it. So then the managers thought, what do we do now? So they said, let's test it out. Let's go and ask some Indian students, international students at MIT in Boston. And they went and asked the students there, and they tested out the razors, and they said, yeah, it's fine, it's good, it's nice, we like it. And they launched it again. And again, it was a flop. And the team, they were baffled. They said, what's wrong? What's going on? Why don't the Indian villagers like it? And now they decided that they'll put a team together, innovation team, and they sent a team of engineers, product developers, and designers to the villages in India, and they spent 3 weeks there. They actually observed how people were shaving and how they spent their time, what their views were, what their likes and dislikes and everything. And they found a lot of insights, and they found how different the shaving habits were of these villages to America, because in the US, they tested it with students where they had running water and they had electricity. But in some of these villages, in some of the small huts, some of these farmers were, shaving in the early morning at 4 a.m. and it was still dark, and they didn't have running water or electricity, and so it was so different. So they learned only through actually doing that empathy stage of being there in the context and understanding the situation and the issues and the problems. And then they changed. They actually redesigned the whole razor, made it a lot simpler, made it lighter, and there are a lot of improvements as well to basically what they wanted. For instance, the villagers were more concerned about getting cut, so they wanted to be safe rather than having a much smoother shave. So they had to redesign the whole razor for the Indian market. So that just shows that, which often even New Zealand companies do, is just export it. They've got this successful product in this country and they think, oh, let's export it to Australia and US, and then they learn it the hard way instead of right from the start, starting with empathy, finding out what people actually want, and then designing the product. This is a fascinating example. It's a Dutch company, fabric manufacturer. They've been around for 170 years, and they use design thinking very successfully. It's a brilliant example because they've been around for so long. Very often companies that have been around for a long time, they tend to relax and think that, hey, we've got a successful product. Why do we need to change anything? We're doing well. But that is the problem. You've got to come up and innovate constantly. So what they did was they actually had, suddenly they found that their sales were going down. There was a lot of competition from the Chinese market. They were actually producing fabric, just wax prints, beautiful wax prints. But because of the problem and the competition, they said, okay, let's apply some design thinking. So they formed an innovation team, and this consisted of people from across each department. Because earlier on, each department was like a silo, but they picked the best person from each department, put them together as an innovation team, and they had a champion to lead that project. And they used a number of design thinking methods like customer journey maps, site visits, interviews, focus group discussions, and they did qualitative and quantitative research, basically first to understand the problem fully and understand where they could innovate. Okay, it's only when you understand that you get that direction and idea of where you can innovate. So as you can see on this slide, they did a lot across 4 countries, 56 shadow shopping, the home visits, 60 home visits. It's in depth. They really spent a lot of time. Video reporting, focus groups, looking at retail environments, and then they summarized all that data into key insights. In fact, if I was doing this as a workshop, I would have actually shown all the list of insights that they gathered, and then how they generated solutions for each of those insights. And then they finally ended up with a tailoring service. So initially, people were the Africans were just going to this Dutch shop and buying the material and then taking it to a tailor. And the problem was there was lack of communication and they were not happy with the garment. So this company called Blisco, what they did is they actually had a training school for their own tailors and kept them in their own shop and fitted them out and gave them a lot of service, the customers, when they came into the shop. And they also had a novel app where the customers could actually see themselves wearing that fabric. And so they were a lot more happier using the product. So this is actually a service example of design thinking. Yeah, now I'll go on to a very simple New Zealand example, something that my students worked on. So I've got the product right here. It's a safety goggles for all sorts of work, like work in the lab or carpentry or tree trimming. They do a lot of outdoor work here, gardening. So the problem, I've just given it in a simple like problem, the method, and the solution. So the problem was there was lots and lots of people with eye injuries, with things getting into their eyes because they were not wearing proper goggles. And also the current goggles were not fitting properly, and it used to get fogged up in this humid weather. And it wasn't keeping especially when they were cutting trees and things, it was grass cuttings and wood chips would go into their eyes. So then they applied the design process. They went through all of the user studies. They looked at the standards. They did a patent search, competitor analysis, and they went and spoke to medical physicians who also mentioned that, this is a big problem for the eyes. And then they came up with a number of solutions and different materials, research and shapes. And finally, they actually gave it to all of these people in labs and workshops and created a product that is really, really amazing, and quite comfortable, different types of mesh and flexible, and they can actually just fold it and put it in their pocket. And so it was really a neat project for them to come up with. So they took it right from the problem up to the solution. So what I often say is, if you're people focused, then you do arrive at identifying the right problems and solving it properly. So this was a success. It doesn't fog up. It's really light and comfortable and flexible, durable, and meets the standards as well. And then we got really good feedback from users saying it's excellent, it's very convenient. And so it's one of the successful examples. This is a small example. The next one is a healthcare company. We've got a very big healthcare company, well, relatively big in New Zealand, and they have 5,000 staff, and they export to many countries. They're basically looking at respiration for sleep apnea patients. So it's CPAP, that's continuous pressure, humidified pressure. I think there's a company in India that also produces something like this called SANS. So they did this whole design thinking process. So they started off with hospital visits. They spoke to a number of nurses. They spoke to parents. This particular project that they worked on, we worked on different products. This was the adult product, which is very successful. But this time it is more about the really, really baby neonatal NICU, the neonatal ICU NICU department, where they have to develop this nasal prongs for a little delicate baby. And that was quite a challenging project. And I'll tell you why very soon. And then they went through and came up with a number of ideas and followed the design process. So here it is. So the problem or the challenge was to come up with something that's comfortable and that provides the effective oxygen delivery to tiny babies. So on the left is a nice little photograph, but when the lead team, along with some of our students, visited the hospitals, this is what they found. The babies that they found were really premature. So some of them didn't even have their skin. Normally, an adult skin has 7 layers. Some of them had 3 layers or probably none, no skin at all. So they had to be really, really soft and delicate when they selected and designed the prongs. The prongs had to be so delicate to go into their nose as well. So what they did was initially did all this hospital visits, spoke to nurses, and actually asked them what the issues were. They said the tubes were too short. They said they have issues with water collecting, condensation inside the tube. The tubes were getting all twisted up, as you can see in this other picture. And it needs to be easy so parents can also use it. The prongs kept coming out of the nose, so they had to make sure that it actually went into that tiny baby's nose. They wasted a lot of time cutting and pasting those little sticky things to the cheeks so that it didn't move when the baby moved. So they actually got a lot of these user needs, and then they converted that to technical product requirements and came up with a whole lot of ideas, as you can see here. Just for each different little part, they did a lot of research on materials. They tried out different designs, and they finally came up with this new tubing. The interesting thing is, in terms of confidentiality, this tubing is protected because they make this in-house. So it's almost like a secret recipe, like Kentucky Fried Chicken recipe. It's a trademark. No one knows how they make that. And then they design all the different parts in-house and came up with this and tested it, several tests. They did all the clinical tests and ended up with that product that's selling 200,000 units per year. I think it's probably selling in India as well. So in conclusion, I still have a few more slides, but I'll just summarize what I've covered so far. So I've covered the design process, the 5 stages, the 6 principles, which you need to keep in mind, and the American example, Gillette, as well as Blisco. Have a look at YouTube. There are lots and lots of Blisco YouTube examples. It's very interesting. The company, the amazing turnaround they made after they applied design thinking. So basically, the takeaway from this session is to use the process to understand the problem well. Don't rush into solutions. Talk to users and stakeholders, and then come up with your ideas and then build, prototype, test. Okay. There are several other methods, as I said, but I can share it in another session. I've also made a little YouTube video called Bright Futures 2. So feel free to have a look at that. Type Bright Futures 2 and you'll see that's basically about planning during change. So how do you go about planning while you're in something like this, like a disruption like the COVID that we're experiencing at the moment? Something that I wanted to share is some of these are frequently asked questions. Very often I get asked these questions. So I thought I'll just explain some of this and it'll take us nicely into the panel session. So one question I get asked often is, how do we deal with confidentiality of an idea? Because often they say, we've got this idea, this is amazing. And if you're telling us to go and talk to users, then our idea is out. So when they say that, what I say is, firstly, very rarely do users actually take the idea and run away and copy. Very rare, okay? But if you feel that it is an idea that is easily copyable, there are several things you can do, okay? One thing is make sure that the product itself is difficult to copy. The other thing is you could get them to sign an NDA. NDA is non-disclosure agreement. That's a simple one-page form. You can get them to sign that to make sure that they don't copy the idea. The other thing you could do is take out preliminary protection. That's what you see sometimes at the back of products. It says patent pending. So when people see that or competitors see that, usually they just stay away. You have that patent pending for a year, so that protects you. And that costs a lot less than the full protection. And the other thing, like what Fisher and Paykel does, is basically develop some part of the product in-house and keep that secret, so your competitors just don't know how to do that particular part. That is probably key to your product. Another question I get asked is, how do we, remember in the design process, they say fail fast and fail early. And people say, but I don't want to fail. So how do you accept failure? So that's something that even entrepreneurs and startup people face a lot, and it is quite acceptable. It is okay. I personally feel you should learn from failure and that's why you're told to fail early in the process. You make something, if it doesn't work, doesn't matter, because you haven't spent a lot of time making it. And with innovation, there's no one right answer. Like in maths, 2 + 2 is 4, but innovation is not like that. You have a number of answers, number of right solutions. So you need to generate a lot so that you can select the best. And it evolves. As you go further and further, you experiment and develop your idea, and then there will be less failures in the future. Failing at the end when you launch the product is costly. Then they ask me, what does a product manager do? A product manager's job is basically to lead the product development process. And design thinking is one process. There are so many other processes. Stage gate process has been around for a long time, and it's still around in many companies. We've got agile from software development, and then there's rapid learning cycles. I can cover all of these different processes, but today I was asked to cover design thinking. And this has its advantages, as I said, in certain areas, particularly when you're exploring a new breakthrough idea. A PM's job is basically like the CEO of the product or the category. So they look after all of it. How can a leader encourage innovation within a company was another common question. So there's several things management and leadership can do within a company. Firstly, they need to share the goals with everybody and show them how each one can contribute to achieving this goal. And then they need to adopt and apply all these best practice methods and processes. They should be allowing for experimentation and failure. It is okay to fail early when it's inexpensive. They should encourage a lot of teamwork and co-design and support lateral thinking, support ideas, get them from internally as well as external ideas, providing incentives and rewards and acknowledgement. Often that is missed out. If some employee comes up with a great idea, management should acknowledge that. And another thing sometimes I find that's missing is rewards for teamwork, to encourage people to work in teams a lot more. So that brings me to the end of the presentation with all the examples and case studies. And I think we can now go to the panel discussion or question time. Thank you very much.
Thank you, ma'am, for enlightening us for your knowledge. We enjoyed your presentation and it will really be useful. Participants can ask any questions, and also you can send the questions through Q&A message box.
I think we take up now the panel discussion, Mr. Surveil.
Yes, sir. Yes, sir. Once the question and answer is over, we will start, sir.
Okay, all right.
Yeah, there's lots of interesting studies going on, different processes. And with PDMA, this is, I've contributed to this book as well. So this is a book we've got as a guidebook for the certification program. So it covers all those areas. And I'm very happy to hear that, with R.M.K, you have the ATV design competition, SAE, go-kart, and you also mentioned some startups and entrepreneurs, and you've got 25 patents. Very interesting. Yeah. Quite amazing. Very, very proud of all the achievements R.M.K has done.
Madam, there is question how to ensure the customization process.
I think that's where you really need to talk to all the different customers. Some companies might just have one group, but you might have a primary group of customers and secondary group of customers and tertiary. So you really need to understand your user groups and segment them. Yeah, and then find out the user needs. There are lots and lots of methods to do that, to find out the needs and prioritize the importance. Because remember, another analogy I'll give you, not all of the needs are important, because sometimes engineers get fixed with adding new features, more and more features and features and features, and that is endless. But you've got to prioritize, because every project has a budget and a time limit. So you cannot do everything within one project. So you might focus on what we call must-have features. And the other one is nice to have. It's only if you feel like, if you have the budget and the time, then you put those nice to have features, but you should make sure you've got the must have features. Another analogy that I can give is, you can think about your solution, and is it going to be like a pill, like a painkiller, or is it going to be like a vitamin supplement? Okay, people want painkillers. So when they're in pain, they will really, so if you find out what their pain points are and come up with a solution for that, they will buy that product. But if it's just a supplement that's nice to have, you may not get that much buy-in. So that's a nice analogy to remember.
Ma'am, one question from a participant, ma'am. One of the students asked, hello.
Yes.
Hey, ma'am, could you share some of the events conducted for students competitions in this area, ma'am?
Yes, definitely. I will, maybe I'll send it to Mr. Mahendran. What you can do is just go to pdma.org, www.pdma.org, and type in student competition. Otherwise, I'll send some more details to Mr. Mahendran. The due date is 15th of July, and individual or teams can apply. So please do that. And there's good prizes. I think there's $1,000 for the team, and you get a chance to get profiled on the PDMA website and all of that.
Another question from a YouTube user. How do you manage conflicts in a team when it comes to ideation or development?
Very good question. How do you manage conflict in a team? So that's why I said you should have a champion or a team leader, usually. And the team leader needs to negotiate that, needs to be able to handle conflicts, and needs to be quite clear and objective about the goals that the group has to achieve. And there are definitely there are certain methods, and one of the main things is communication. It's just making sure everybody's on the same page, everyone understands what's required, and trying to be objective about it and documenting some of the process and methods. Yeah. Any other question?
Any question from participants?
That's good. Good to see the students you come. It's really amazing that you're taking the interest to learn, and definitely we'll offer some more based on your interest. Tell us what topics you'd like to learn more about, especially in this entrepreneurship innovation area.
Ma'am, one more question.
Yes.
How to decide about frequency with which design changes need to be happened?
Good questions. They're thinking very good. How often? Frequency? Well, I think at some stage you've got to freeze the design. You can't keep changing forever. So that all depends on what timeline you have and the budget and resources you have and how important that change is. So you really have to, that's why we have this other method called QFD, quality function deployment, which actually measures how important each of those changes are. So if it is a critical change and it is something that is of value to the users, then it's worth putting. So you've got to look at that cost benefit analysis and decide. If it's not that important, then you keep that for the next iteration, next product, and put this out now. Yeah, that's some of the decisions and calls that the product manager will have to make, because you are the product manager is most familiar with the product category and has a very good handle about the importance of those features to users.
Yes, ma'am. Thank you, ma'am. Another question. Nowadays, there are many innovations are taking place daily. So is it difficult to convert innovation into a startup?
No. Innovation is basically the commercial version of invention. So if you're going to start up a company, you've got to have a good innovation or some interesting product to start it for this, otherwise you're going to be building your startup and business model around that. So it is important, yeah, to have the innovation and to then form your team. Even though you might be heading the startup, it's always good to have a team of different experts, because as I said, product development and innovation is not a solo game. So you should put a good team to back you up and to support you throughout. And there will be ups and downs, as I mentioned. It's not easy, but you should be persistent and continue.
Thank you, ma'am. One more question, ma'am. Many products and services are going for social media for advertisement rather than simply relying on e-commerce sites. What are the innovative ways of encouraging customers to understand the product?
That's a very general question. It depends on the product. So again, look at the user perspective. Where are your users spending their time? Are they spending it on Instagram or Facebook or on the website? If they're spending a lot of time on Instagram, then that's where you need to be. So it all depends on where your customers are spending time. What are their habits? That's why you need to understand that. It's not about you, it's about the customer. Yeah.
Thank you, ma'am. One more question, ma'am. Greetings. Just in curiosity, I thought to ask this question out of box. What's your opinion on job opportunities, especially for freshers after the lockdown in New Zealand? Also, what's your opinion on pursuing masters in product development and its opportunities, madam?
I thought I might get one of those, even though the questions are to be on the topic. Definitely, we do have master's, PhD in product development. Job opportunities in New Zealand, as I said, things are a bit tough now. Although the government has done a great job of getting rid of the virus, and we're a lot freer now. In fact, it's one of the world examples now that we are free and free of the virus. Jobs, it depends. I feel it depends on how well you do in your project, your final year project or your master's theory and project. If you do an amazing job, then you get snapped up. But no, otherwise, it takes a while. So I would say just focus on what you're doing and do that well. And then if, people will be impressed and definitely they'll want your skills. So it's all about upskilling and being good at what you do. Yeah.
Thank you, ma'am.
Madam, one more question from Dr. Suresh Babu, Professor, College of Engineering, Anna University, Gindi. Do you think Indian engineering curriculum need to be changed with changing scenario of the engineering requirements with the background of requirements of creativity and innovation?
I don't know in depth what the curriculum has, but for sure, absolutely 100%, I would be passionate about putting in some creativity, innovation, and entrepreneurship. It's so important because very often engineers want to be entrepreneurs. So we do need engineering entrepreneurship, and we do need them to have some hands-on practical projects like this where they get to apply their theory. I think it's interesting for the students. They learn a lot more when they actually apply it. And I think that makes them more employable. And that's why we have final year projects are with industry. We base it on, we go to industry, we get their problem, and the students work in teams on the industry problem. Yeah. So they get a very good understanding. And often I tell them that final year project with industry is like a long interview. It's like a 1-year interview. So if they perform really well, it's like they've done well in the interview. A lot of our students get a job by mid-year, 4th year. Yeah.
So, Kadirvelu sir?
Yes, sir.
I think there's a time to start panel discussion because
Yes, sir.
We started receiving thanks messages and also appreciation messages from the participants.
Okay,
Lovely.
Thank you, ma'am, for this wonderful session with us. Now I invite Mr. K.R.A. Nair, Director Retired, Lucas TVS, starts the panel discussion along with Mr. S. Krishnakumar, Vice President Retired, Lucas TVS, and Dr. C. Jabaraj, Professor Retired, Anna University. Please, sir.
So before that, I would like to inform that our Dean Sir, Dr. K. Chandrasekharan, is not able to join because of some technical issues. He has conveyed his regards to all of you, Madam, Sirs, everybody.
Thank you. Thank you.
I requested panel members to log in on video. How to get their screens on
on the stream. Hello?
Yes, sir. Three of them are there, sir.
Can I go ahead?
Yes, sir. You can start, sir.
Okay. Now, first of all, I want to compliment and thank Professor R.M.K for a very good introduction to design thinking, which I believe is not very commonly taught or exposed in our Indian universities and students, even in our engineering industry in India particularly. There are some organizations, particularly in the software area, who is doing or applying design thinking. But generally, this approach is still not very prevalent in the industry. And this exposition by Professor R.M.K, I hope will give impetus for people to study about it, understand it, and apply for that, because it's a very powerful tool. It's a very important tool, and a tool which will lead you to great success. Now, I only want to touch upon a few things on design thinking, which Professor R.M.K has explained. And one thing I wanted to tell you is that if you look at consumer product, it is told that anything between 90 to 95% of the product globally that comes on the shelf of the supermarket fail within 1 or 2 years' time. Similarly, engineering product which comes into the market, about 60 to 70% of them fail to return the investment that is made on it. Now, this is a colossal waste globally. And one of the main reasons why these failures or business failures happen is lack of understanding of the customer. And that is one reason design thinking is an important tool. Design thinking starts with focusing on understanding what the customer needs. If you look at engineering industries, generally it is the marketing department who comes and tells us that we need a new product or a new service, and then engineers and teams formed for this product development go by what the marketing department is saying. Many of the engineering teams or product development teams have no direct contact with the customer, no direct understanding with the customer, or no clear perspective of what the market requires. They work on engineering specifications. This is one of the changes that need to be implemented in the organization for success. And design thinking has many tools, as Professor has explained, to understand the customer. And again, understanding the customer is not sending a survey form or just asking the customer what do they want. Basically, it is understanding the customer need, which sometimes the customer themselves may not be able to articulate very well.
Okay.
So we need to observe the customer in the context in which the product is likely to be utilized.
Correct.
For example, Professor explained very clearly the respiratory system for newborn babies. Now, any amount of literature survey or questionnaire will not give you a good feedback on what exactly is required by the newborn babies of different nations or different ethnicity, etc. You have to go and see them. You have to meet them, meet them in that context and understand in that context. And this same thing is similar for many products. Now, this is something which has to be inculcated in designers, that understanding customer requirement is the first and foremost part of it. That is one lesson I learned from design thinking. The second part is prototyping. Generally in engineering industry, prototyping is done much later in the design stage. We get a specification, we do all the engineering calculations, we do the simulation analysis and all that, and then build a prototype for the purposes of validating the assumptions we have made in the design. This is much later stage in the design process. Instead of that, or in addition to that, what is needed is building prototype, as Professor has demonstrated by some pictures of it, what is called a Lasher prototype or low fidelity, low cost prototype at the beginning of the product development process to confirm that your understanding of what customer require is correct. It is not for validating your design calculations. It is for confirming your understanding of customer requirement is correct, which will make you doing the right new product development. And mostly we are today concentrating on doing the NPD process right. This has to be understood clearly by design engineers. So customer understanding is very vital for product successes. And prototyping in the early stage is another important change in the mindset of engineers we need to create. And not only that, we also need to have iteration of the prototype, interacting with the customer, then pivoting it, making new prototype, getting further interaction with the customer, changing it again. That iteration process should go through as many times necessary to understand the customer requirement fully. And then another one, mindset or a culture which is required to be built within the new product development organization is learning from failures. Failures are generally considered to be a bad thing, but that is not correct. Failure gives you an opportunity to learn it. Failure to be treated as a feedback mechanism to tell us that our approach or our methodology or our results which are obtained is not meeting the customer requirement, and hence we need to change it. So getting hold of failure as early as possible, like Professor said, fail early, fail safe, is another vital lesson which we need to understand from it. We also need to understand the basic difference between want and need. For example, you may say, I want a Coca-Cola or I want a Sprite. That is a physical need for a physical product or a service to meet an underlying need. The need here is, I want to quench my thirst. So when you look at the need, you get different alternatives possible to do it. So you may, product designers or product concepts generation stage, we need to have a clear understanding between product need or customer need and customer want. Fundamentally, if you focus on solving customer need, we will be able to come out with many alternative solutions which can then be further converged and good solutions can be generated. So these are some of my observations and comments. Thank you. Krishna Kumar, may I now request Mr. Krishna Kumar to make the comments?
Yeah, actually, Dr. Aruna Shekar, I think you have given a very clear understanding of how to do this design thinking in a small nutshell.
Yes.
Even though it is so small, it is more very, very difficult to do it in the real industrial context. we have been trying to do this in my earlier organization, and we try to do some work on that. In that process, we learned a Japanese technique called quality function deployment,
QFD.
wherein we pick up unspecified needs of the customer. And when we try to do this, there is always a shortage of time. People in new product development group or engineering don't have much time to do this in a proper way. So we rush and get into something else and finally end up in a failure sometimes. And to reduce the chances of failure, design thinking process, which is similar to quality function deployment in Japanese context, is very useful. I have seen a lot of improvements made by Japanese companies, not in the name of design thinking, but in the name of QFD. For example, I have seen in Maruti Suzuki, Nissan, there are a lot of things which they have done. In India, in Indian context, as Mr. Nair said, failure is taken as a real punishment. He is given a punishment. I don't know whether it is always in Indian context like that, or has it developed in the recent past, maybe in about a decade, about a year, or in a decade or a century, wherein people don't want to accept failures because we want fast action, quick results. So these are all some of the challenges. I have seen in the Indian context, one of the examples which I thought I will explain here. I don't know whether they have done it through design thinking or by any other process. You know, there's a tender coconut we used to get in Chennai and other places in South India. They take a coconut and then they, cut the outer fiber and make a hole with the same, and then put a straw and drink. Now there is somebody who is selling tender coconuts in Chennai, which has got a machine. In the machine, he has cut off all the fiber and made a small hole on top. He has done more of a trepanning. He has not cut the inside coconut. Coconut kernel is not cut. Only the shell is cut with a small hole, about 10 millimeter diameter. And he has put a cork and a small lock like Coca-Cola can. The Coca-Cola can has got a pullable thing. So like that he has done, and he's marketing it. He calls it first time in the world. I don't know whether it is true. Now what I'm trying to say is, it is definitely necessary for us to understand what the customer needs and then put it into our product and make sure that our product succeeds. But the time becomes a constraint many times. So wherever, to the extent possible, we have to try this in our industry. But when we go into the website and things like that, as I was telling Mr. Nair also earlier, we don't find many industrial examples. We find examples from IT and other MC, some of the things like that. I also know that today, companies in India, for example, Ford, they follow design thinking in a large way. They're trying. I don't know whether they are successful, but they are trying. And Mr. Nair was talking about prototyping. Basically, virtual prototypes may be faster in the initial stage, but how far we can do it is very difficult because you have to build a lot of knowledge and information on that. And of course, iterations, where, as I told you, due to paucity of time, many products fail because we don't iterate properly. We do something or other and then say that this is a product and we try to sell and get into a problem. I think these are all some of the observations which I made. And I think by training the students in design thinking, which I wanted to try in R.M.K. sometime back, about 2 years ago, and we tried, because I have taken a lot of inputs from Mr. Nair, who has been an expert in design thinking initially. Nowadays, I don't think he finds a lot of time to do that. But I've taken a lot of inputs from him and then tried to do that. But still, it has not pierced, it has not broken the shell. So we have got to do that. In Indian context, it is definitely necessary because we are trying to open up and say all we should make in India and grow. That is the present context in COVID-19 situation. Thank you.
Okay, thanks, Krishnakumar. Now, may I request Professor Jabrabs to make his observations and comments, please?
Thank you, sir. Well, we've been listening to Aruna on her many of the success stories, both from her school point of view and her interaction with the industries. Well, I'm also one of the academicians. Maybe I'll take the question which came from one of the audience. Should our Indian curriculum should be changed so that there will be innovation and creativity added up? Well, if you say that the topic today is stay ahead with your innovation and design thinking, and if the industries has to stay ahead, they must be pumped with new blood, which is going to be through the new recruits of the engineers from the institutions. So the institutions must be imbibed with the knowledge on innovation and design thinking. But how it is going to be possible? A prof in the academic institution, how is he going to learn? So therefore, who has to build the cat first? Is the industry has to build the cat first, or the institution has to build the cat? And it has to come together. But there's, at least in Indian context, either the industries are thinking, institutes or colleges are only giving the book knowledge, and so the institute is producing engineers who are not fit for the industry. And the institutes are of the opinion, oh, industries are either having everything secret and nothing is known to us, so we will not be able to teach our students. Or sometimes they say industries are following age-old theories, industries are following age-old design customs, so we are not able to make any improvement. In my understanding, the place where I was teaching in Anna University, we have made a change by this way. When I as a professor could admire, could appreciate industry man like, say, Krishna Kumar or Nair. Similarly, when Nair could appreciate the knowledge of a professor like Chandrasekhar or Javraj, there is a good flow from each side. If that mindset, when I started appreciating, I'm able to understand. When the industry started accepting, then they are able to get it. So this is one of my observations. This mindset of the industries accepting institutes and institutes appreciating the real world of the industries, it will do a long way to go. My second point, I remember when I was teaching, I changed my notes and everything. And one of the slides will say, who designed a new product? So there will be three options. Then it was said, the marketing man designs, or the manufacturing person designs, and the designer designs. Actually, we heard the first priority goes to the marketing man because he says, what is the relevant product? Well, he has brought it. The manufacturing guy will say, it's impossible to make a product like this because he's got his own limitation and constraints. And the designer will say, well, I have to make a whole lot of changes in the design and it's going to be costly. So finally, nobody designs. The existing product goes on. Well, again, I will say a trade-off among the three. The marketing man, yes, you bring the real situation. Yes, the manufacturing man, you are the one who has to bring out the product. And a designer, see how these two can be linked up. But then what is the difficulty is either we don't have appreciation for one another. Oh, marketing guys, they did MBA, they don't know anything about engineering. Oh, manufacturing guy, he's got his good old machine and he doesn't have the new machinery. But then everybody will blame the management to say management doesn't give us money to revise our shop floor. Management doesn't give us money for the real needs of the industries to be addressed to. I think if we could appreciate one another, then we will be able to do still better. Uh, I believe the real innovation comes if we could understand one another, appreciate one another, and learn from one another. Well, everybody was appreciating, my third point, everybody was appreciating failure is an opportunity to learn. Good, agreed. But then, how many management will be willing to lose their marketing? They were the leaders, and their new design, the innovation has put them as number 2, put them as number 3, put them as number 10 and below, then he lost the whole game. Nobody would like to have the failure acceptable one. And the man who invested the money, the MD of the company, he wants return on investment. How much failure can fit in there, or how the failure has to be fitted in there? I have my own questions on that. I was very excited when I was finishing my academic career. I learned about this disruptive technology. Today, disruptive technologies are the ones which are thriving. Okay. In the name of disruptive technology, yes, it is true, we have brought the Gillette razor. Okay. And they are trying to take the Gillette razor to every nook and corner of this country. Remember, it was made either in New Zealand or in Germany, wherever it may be. They are trying to see India as the dumping place. Okay. Now, what happened to the Indian system of shaving? And we simply, there is a community which was doing this job. Now they become useless. There is no job for them. The whole concept of disruptive technology, how much we have to accept this as an innovation, I have my own question on that. Well, I'm glad that the discussions of today has given a new insight for thinking anew, because there is no end to it. There is no day when we will say there is no need for a conference on innovation and design thinking, because we have already achieved everything, we will keep on. So in that count, I'm glad today we have added one more for the people to think, for the audience to think, especially for the new generation of engineers and graduates to think. I'm thankful to Aruna, Shekar, and for the other members of the team to throw some of their thinkings so that people will be challenged to think better, so that as the year goes on, there has to be new innovation, new design thinking. And we have made some attempt today. I thank you very much, one and all. Thank you, Nair Saab. Bye.
Thank you. Professor R.M.K, may I know you would like to make some further comments on it?
Yes, I thought there were very interesting comments from each one of you in the panel. I totally agree with many of those comments, but the last one I remember well is what Mr. Jebaraj just mentioned about disruptive innovation. I totally agree. There are quite a few of those examples where I think it's really important to consider the impact on that local community or society or village. That's extremely important for all engineers and technologists to consider. What is the full life cycle of their product, and what is the impact on society? They must think about that before they even put it out there. That's absolutely. I know there's another example where they put a big, large overseas company, American company, I think, dumped this stuff on some local community, and I think it was shoes, Tom's shoes, and then all of those people, the shoemakers in that village, lost their jobs. So those sort of long-term effects must be considered. Absolutely, there's no doubt about it, and that's why now we've got a whole new chapter on sustainable engineering and sustainability, and that whatever innovation you come up with, it's not only for the end user, but that's where you've got to consider all the stakeholders, and you've got to consider the benefits, not only to the manufacturer, but to society and the environment. Yes.
Okay, I think we've already taken about 2 hours of time.
Yes, sir.
And hence, I mean, new product introduction.
Sir, sorry for the interruption.
Go ahead.
Sir, with your permission, sir, one last question from one of the participants, Mr. J. Venkatesh. Is actually our alumni, belong to the batch 96 to 2000. This is the question actually asked to the guest speaker. How would this framework be useful in highly critical safety industries like aircraft design and aircraft engine design? Are there any case studies available, please, ma'am?
Yeah, so this is not the only process. As I mentioned, there's a stage gate process, which is a lot more controlled and regimented. So sometimes you've got to do this design thinking initially and then get into the stage gate process. There are examples, definitely. And as I said, the range of the product type is so different. So something as precise as aircraft engineering and rockets and spaceships, yes, we've got a new spacecraft here and rocket company as well. So there's a lot of testing. The testing and safety is so important there. So definitely the life cycle or the development cycle is much longer in those cases, not as quick and short as a fast moving consumer good in a supermarket. So there are various processes, various stages, and various lengths of the processes for different types of product. Definitely, we do have that.
Now, sir, I'll take 1 minute, sir, to just share my thoughts, and I have few clarifications also. So regarding design thinking and innovation for the grown countries abroad, we have a strong patent, everything is there. But in countries like India, we are upcoming country. Suddenly, if some innovation happens in India, it is rapid prototyped. So immediately it is copied, and they are manipulating and making a new design. And again, they are redesigning and sending into the market. So how countries like India or in our student community also, as you have appreciated, we have a lot of patents, but still the patent establishment is not very good in our very fast, I can say. So industries are protecting somehow their design, but for students, how to protect their innovations in academia? This is the question to the panel. So I request any one of the panelists to.
India has very good patent laws, basically. We follow the Paris Convention and we have very good patent laws in this country. What is aware is that it is not, people are not well aware of how you can protect your invention, how you can defend your invention if somebody else copies, etc. Many of the patents that I have seen Indian patents written is not very legally good. They describe the technique and technology, but it is not worded very properly because it is not written by proficient patent attorneys or patent drafters. That's one observation. The second one is the the copying of something, if you can prove that your patent or copyright is violated, you have to go to the court. There is no alternative for that. And there are cases in India where invention by in product introduction by even large companies by their competitors by challenging them in the court. But unfortunately, the going to the court takes time, money, and effort. There is no alternative. That is the same case with whether it is US or Germany or anywhere. Patent violation is common and very prevalent, and people protect it against that by going to the court. And if you demonstrate, a company demonstrate that their patents will be actively protected, people will hesitate to copy it. Now, for example, I don't think that there is even a discussion about patent and what is patentability, how to write a patent, how to apply for a patent, etc. in the academic circles. There may be a patent department, but mostly students are not exposed to it. That's one thing. The second thing is, today, Government of India has announced that if you are a startup company by a student or anything, the cost of taking a patent is much cheaper. There is a process of making a very fast patent provided by under the startup scheme. These are my observations.
Thank you, sir. Thank you.
Okay, now I will return the control to the organizers.
Thank you, sir. Thank you, sir. So thank you very much, madam. So really, it's a very, very nice and wonderful session, very informative. So we have seen so many messages to thank you and also to appreciate your session in the both in the Zoom and YouTube chat boxes. So it's really a very informative session, and definitely all the participants, so they'll take some very sincere efforts because of this session to stay ahead with respect to their product innovation, design thinking, and also creativity. And regarding the panel discussion, so definitely, so it's also a very useful information shared by the genius experts. So we could able to see their knowledge level with respect to their experience and expertise. So totally, it's a knowledge sharing session. So on behalf of, once again, I'm on behalf of our respected chairman, sir, all the members of the management, all the participants, including myself. So I would like to thank our Madam Aruna Shekar, Madam, and also Dr. Krishna Kumar, sir, K.R.A. Nair, sir, and Dr. Jabraj, sir, for giving such a wonderful session, including the panel discussion. Thanks for organizing this excellent webinar to our mechanical HOD, Dr. K.R. Sindil Kumar, and also coordinator, Dr. Kadirvelu, and all the faculty members of Mechanical Engineering Department. So I thank each and every one of you for providing this great opportunity to all the participants across the country and also outside the country. Thank you all. So
many thanks.
Thank you.
I wish you all safety.
Kadirvel, sir, please, a formal vote of thanks by our Kadirvel, sir.
Yes.
Coordinator.
Thank you, sir. Good morning to one and all present here. It gives me immense pleasure to propose vote of thanks for this online webinar organized by Department of Mechanical Engineering, R.M.K. Engineering College. First, I wish to express my sincere thanks to guest of the speaker today, Dr. Aruna Shekar, Professor, Massey University, New Zealand, who readily accepted and gave a nice presentation amid her busy schedule. Thank you, ma'am. I extend my thanks to panel members, Sri K.R.A. Nair, Director, Retired Lucas TVS, Mr. S. Krishna Kumar, Vice President, Retired Lucas TVS, Dr. C. Jabraj, former Professor, Anna University, along with Dr. Aruna Shekar for the healthy and fruitful discussion today. Thank you, sir and madam. I express my sincere thanks to R.M.K. Group of Institution Management team for their constant support to make this webinar a memorable one. I also extend my sincere thanks to Dr. K. Muhammad Junaid, Principal, R.M.K. Engineering College, for his guidance to make this program a successful one. My special thanks to our Dean, Dr. K. Chandrasekhar, for their extensive support and cooperations in all our effort. I extend my sincere thanks to Dr. K.R. Sendil Kumar, HOD, and webinar coordinators, Dr. Mahendran, Mr. Ramesh, and Mr. Navin Raj for their sincere contributions, and all the faculty members of the mechanical department for their fullest support to bring a large number of participants to this program. My sincere thanks to Mr. Adnar Iswaran, System Admin, R.M.K. Engineering College for his technical support. Last but not least, I extend my thanks to each and every one of the participants to attend this webinar. Hope you have enhanced your knowledge. An important notes to all the participants. We will send the feedback form to your registered mail ID. Kindly fill the form and send it to us. E-certificate will be sent to you within a day. Thank you, one and all.
Many thanks. Thanks, everybody.
Thank you. Bye.
Thank you. Nice of
Thank
you.
you. Thank
Yeah.
you. Bye-bye. Bye.
Bye.